Hello students, welcome back to my channel Influence Mathematics. I hope you have watched the previous video and understood the basic concept of the chapter. In the last video we have discussed about exercise 6.1. Here in this video we are going to discuss for exercise 6.2. Exercise 6.2, question number 1. Let's see the question. Identify the monomials, binomials and trinomials. So before we start doing the questions of this question number 1, let's understand what are monomials, binomials and trinomials. Whenever an algebraical expression will be given, if one term is there in that expression, then that is called monomial. Okay? And if two terms are there, then that is called binomial. And if three terms are there, then that is called trinomial. For one term, that is called monomial. For two terms, it is called binomial. And for three terms, it is called trinomial. So let's see question number 1. X square plus y square. This is one term, this is the another term. Okay, this is one term, this is the another term. So the terms will be separated from each other with the sign plus or minus. If in a term, just like say x square y. Now these two terms are not separated by the sign plus or minus. They are not separated. There is no sign, that means into is there. Okay, so in that case this together is one term only. Okay, so remember, whenever the terms will be separated by the sign plus or minus, that time only we are going to take those terms as different. Otherwise, if the terms are in a multiplied form, then we are going to take it as a one term. Okay, so here x square y square separated by the sign plus, right? So with the operation plus or minus, if the terms are separated, we will take the terms as different. So this is one term, this is another term. So here two terms are there, so that's why this algebraical expression will be binomial expression. Okay, this is a binomial expression. Now let's see the number 6 of question number 1, number 6. Here you see this is one term, because these two ax square, these are not separated by plus or minus, right? So this we are counting as one term. B, this is separated with the plus sign, so this will count as the second term, and this C will count as the third term. So here how many terms together? 3 terms. So this will be trinomial expression. And let's see number 4. Number 4 is AT. Now this is not separated. This AT are not separated by plus or minus. This is in the product form. So this we are going to count as one term. Okay. So when it is one term, what we call it? We call it as monomial expression. So monomial expression. Done. Let's see number 11. Number 11, see, minus 7x plus 2. Here this 7x minus 7x, this is one term, and this is another term separated by the sign plus, right? So how many terms together? 2 terms are there. So when 2 terms, we call it as binomial expression. So remember students, and one terms will be there, that time we will call it as monomial expression. When 2 terms will be there, we will call it as binomial expression. And when 3 terms will be there, we will call it as trinomial expression. Now let's see question number 2. Question number 2 says what? What does the question say here? Question says, write the coefficient of x in the following. Now what is coefficient? Okay, coefficient of anything, of an algebraical expression, of a term, in a term, when it is asked that coefficient of x. Now whatever is going to be multiplied with this x, that one, the multiplied one is going to be the coefficient of x. Just say I am telling you 4y, and I am asking you what is the coefficient of y. So what is multiplied with y? 4, right? So we are going to say coefficient of y is 4, like that. Okay, whatever is multiplied, that extra multiplied one is the coefficient of that variable. Okay, now here see coefficient of x. Let's see here. Number 1, 4ax. What is the coefficient of x? If you leave x, then what is remaining? Only 4a is remaining, right? So coefficient of x is what is the coefficient of x? That is 4a. Okay, now let's see number 2. Number 2, see here coefficient of x will be what? If I omit this x, then what is remaining? Minus 10yz. So coefficient of x here, coefficient of x is minus 10yz. Okay, let's see number 5. Here see coefficient of x here will be what? If I omit the term x from here, from this term, then what is remaining? Minus 5 by 2 yz square, right? So that is the coefficient of x. That means the remaining multiplied terms, the factors. Okay, so coefficient of x is minus 5 by 2 yz square. Done. So this is how we got the coefficient of x in this question number 2. Let's see the next question. Now see, when it was asked in question number 2, coefficient, only coefficient, that time we have not seen that whether we are writing down variable or we are writing down constant. If it is only x coefficient, that means the remaining multiplied terms of that variable. Okay, remaining multiplied terms of that variable, whether that multiplied terms are constant or variable itself, that doesn't matter. Okay, right, like here x minus 10 yz, here minus 10 is constant but yz's are variables, right? But all this will come for the coefficient. But in question number 3 they say numerical coefficient. Write the numerical coefficient of each term. See here, this is one term, this is one term, this is one term, this is one term. Okay, so numerical coefficient of each term. When numerical coefficient says, we have to write down only the constant term of constant value of that term. Okay, so now here this is one term. Here what is the numerical? Can you see any constant term? We can't see. That means 1 is multiplied. If nothing is there, no numbers are there, no constant term is there, that means what is there? 1 is there. 1 comma, here what is there? Minus 7. Here what is there? Plus 5. So 5. Here what is there? Minus 2. Okay, these are the numerical coefficient of each term. Okay, here 1, minus 7, 5, minus 2. Right, now let's see only the numerical coefficient, only the constant terms you are going to the constant values in a term. Numerical coefficient means the constant value in a term. Constant values in a term, not the constant value, not the constant term. Okay, this is the complete constant term. This totally, it is the mix of constant and variables. These are the mix of constant and variables. This is totally a constant term that we have discussed in the very previous video, right? But here the question did ask me to find out only the constant term. If they say only constant term, then I will write only 2. Only 2. Minus 2, I mean. Minus 2. Okay. But they said here numerical coefficient of each term. That means the constant value in each term. Constant value in each term. In this term, what is the constant value? 1. In this term, what is the constant value? Minus 7. In this term, what is the constant value? 5. In this term, what is the constant value? Minus 2. I hope it is clear. Coefficient and numerical coefficient. When coefficient will come, then they will say coefficient of x, coefficient of y, like that. Okay. So that time, leaving that x or y, we are going to write down the remaining multiplied variables or the constants. Okay, of that term. But when they will say the numerical coefficient, then we will write down only the constant value of that term, constant values of that term. Okay. Now here you see what are the constant numerical coefficient. In this term -2, in this term +7, in this term -6, in this term 8. Done. Now in number 4, let's see. This is a term. What is the numerical coefficient? 4. This is one term. What is the numerical coefficient? -3/2. This is one term. What is the numerical coefficient? 5/2. So this is numerical coefficient. So till now we have learned about monomial, binomial, trinomials, 3 types of algebraical expression, and coefficients, how to find out the coefficient, and how to find out the numerical coefficient. Now let's see question number 4. Question number 4 is just like question number 2. They said here only coefficient. Only coefficient. So according to that we are going to do. So what did they say? Write the coefficient of y in this term. Okay, we have to write down the coefficient of y in this term. Okay, in the previous question a fixed coefficient of a fixed value was given. Coefficient of x for all the terms, right, in the question number 2. But here it is different for each terms. Okay, number 1, y in -5y. In this term for y, what is the coefficient? In this in this question for 2 in 2ab, in this term what is the coefficient of a, like that. So here let's see coefficient of y in -5y. Coefficient of y in -5y is, what is that? Y in -5y, right? Let's omit y, then what is remaining? -5. So -5 is the answer. Got it? Let's see the next. Coefficient of a in 2ab is, omit this a, what is remaining? 2b. So 2b is the answer, is 2b. Okay, let's see the next. P in -3pq. Coefficient of p in -3pq is, p omitted, what is remaining? -3q. -3q. Okay, now let's see here. Coefficient of x cube. Coefficient of x cube in x cube plus 1 is, now see here, this 1 is the another term. This one is the another term, nothing related with this term of x cube. Okay, here no x cube is there. So this plus 1, because since plus is there, so this has been separated by one term. So we cannot write down this plus 1. We cannot touch this plus 1. Okay, we are not going to calculate on this plus 1. Okay, so let's only see x cube. What are the terms multiplied with this x cube? Because we are going to find out the coefficient of x cube. Okay, so nothing is there, no numbers, no variables multiplied with this x cube. That means only what is there? 1 is there. If no numbers is multiplied, that means what is there? 1 is there. Okay, I hope it is clear how to find out the coefficient, numerical coefficient. Let's see the next question. Now here see, write the constant term. Only the constant term did they say. Here they are not telling numerical coefficient. Okay, there they are telling constant term. When it is constant term, that means where there is no variable, the term in which there is no variable, no x, no y, no z, no a, no b, no c. Okay, here x is there, so this is not a constant term. Here x is there, this is not a constant term. Here no x, no a, no b, direct a value as a very fixed value, that is -7. -7. So constant term is equal to -7. Okay, now here what is the constant term? This is not a constant term, this is a variable, so this -9. Constant term is -9. Okay, now here what is the constant term? Constant term, here it is +3. I hope it is clear how to find out the constant term and the numerical coefficient of each term. Okay, that is the difference. Write all the terms. Let's see question number 6. Write all the terms of each of the following algebraical expression. We have to write down all the terms. We have to separate out all the terms here. Write all the terms of each of the following algebraical expression. This is one term, this is another term, this is another term, this is one term. Right? These are all the terms. So a cube we are going to separate. So whenever we are separating, we'll give comma. Okay? Comma plus b cube. No need to write plus. If you don't write plus also will do. Okay? If it is minus, then you have to write. Okay? B cube. There minus is there, so you have to write down comma minus 3ab. This is one term. Comma this is plus 5. So a cube one term. Comma b cube another term. Comma minus 3ab one term. Comma 5 another term. Comma. Okay, like that. Let's see the next, number 2. 6xy minus 4x square minus y square plus 5. This is one term, this is one term, this is one term, this is one term. Okay, so 6xy one term, minus 4x square one term, minus y square another term, 5 another term. All are separated with comma. Remember that. Okay, now here number 6. This is one term, this is another term, this is another term, this is another term, this is another term. Okay, so let's separate each other with putting comma. X comma 2xy comma minus 3x square comma minus 8y comma minus 6. Okay, so these are the how to write down the terms separately from each other. Okay, in this question number 6, write all the terms of each of the following expressions. So we write down. Okay, let's see the next question, question number 7. Here they say the like terms. Like term means the terms which look similar, Okay, now see here x square y square x square y square. What is multiplied with that? Let's not focus on that. Okay, let's not focus on that, but let's see the variables. Okay, let's see only the variables. X square, this is also x square. So these are similar. Yes or no? This is 1x square, this is 4x square. These are from the same family. Right? 1 cow, 2 cow. Cows are all from the same family. 1 dog, 3 dogs. Dogs are from the all same family. Right? But I cannot say 1 cow and 3 dogs. That cow and the dog is from one family. Cannot say that one. Right? So we have to make out family. Members from the each family are the like terms. Members from the each family are the like terms. So this is x square, this is also x square. So they are like terms. So x square comma 4x square. This is one like terms. Okay, and another one is and y square comma 3y square another are like terms. Are like terms. Done. In this way, let's see the next question. Question number 2. Here see 2x square. As I said, let's not focus on the constant value. Okay, we will see only the variables. Here see x y square. This is x y square. Let's see any x y square family is there or family member is there or not. See this one also x y square. But this is x square y. It has no partner. X square y no partner. So it has no like terms. Okay. But here this is x y square. This is also x y square. Same, right? Though the numbers are different, but the variables are same. Yes or no? Since the variables are same, so that's why these two terms are the like terms. Okay. So 2xy square comma 4xy square, these two are like terms. Okay, I hope you can write down how to do the like terms. Let's see one more from the like terms. Number 6. See here, number 6. X square y square. Let's see any x square y square is there or not? Here. X square y square, though it is written invertedly, but since it is multiplied 1 into 2 also 2, 2 also 1, 2 into 1 also 2, right? So no problem. X square y square x square, same thing only. So these two are the same term. Let's see any more is there. Yes, one more is there that we can see. One more is there. See x square y square, right? Yes or no? So x square y square, this is also x square y square, this is also x square y square. So these are all from the same family. So x square y square comma 4y square x square comma minus 3 x square y square. These are all like terms. These three are like terms. Okay. Next, see again any more. This 4xy. Any xy family member is there? Not there. Xy square. Any family member is there? Not there. So it has also no partner. It has also no partner. So no like terms. So these three are like terms. Like terms. So this is how we are going to find out the like terms. So the last question of the exercise, identify the like terms in the algebraical expression. The same thing, the same time. Okay. See x square. Any x square is there? Oh yes, 5x square. This is also x square. This is also x square. Any more? No, not there. So x square comma this is minus 5x square minus 5x square. This is one pair of like terms. Okay. Now let's see xy. Okay, xy is there? Yes, is there. Again, any more is there? Yes, it is there. So three are there, right? Xy comma minus 7xy comma xy. Three pairs are there, right? Three are there. So these three are one like terms. Okay. So this finish, this finish, this finish. Now these two remaining. Minus 9, no constant terms. X, no x members are there. So they have no like terms. So these two are one like terms. These three are one like terms. So are like terms. Done. 4x x square y. X square y. Any x square y is there? X square y. We have to see very carefully. Sometimes it will be given invertedly also. Just like here. X square y. Y x square. So you have to see very nicely. X square y. X square y. Square is there on x only. Y. So same thing only. Okay. If it was supposed to be y square x, then it was not supposed to be same. But x square y is also x square y. Same only. So 4x square y comma 7yx square, these are one like terms. Again, any this xy, any xy, no. 3 and no constant terms. So only these two are like terms. Okay. So this is how you have to solve out for exercise 6.2. I hope it is clear. Watch the video of this exercise as well as the previous exercise repeatedly to understand more clearly. Very soon I will be coming out with the next exercise in the next video. Till then, practice well, be at home, stay safe. It's Nirmal Roy signing off.